Hi everyone, welcome back to ICS 111, Intro to Computer Science 1. In this video, we'll be looking at compound conditions and Boolean operators. A compound condition is when the condition is made up of multiple criteria. Boolean operators are the types of operations you can do with a Boolean. In the previous video, we started our journey into control structures. Control structures alter the normal flow of execution in a program based on a condition being true. The basis of control structures operate on Booleans. Booleans are logical values, true and false. You can think of them as yes or no. We were introduced to the comparison operators, which are used to compare primitive values. The evaluation of a comparison is a Boolean. With an intro to Booleans and comparisons, we looked at the if statement. If statements are how to implement decision-making in a program. If a condition is true, then execute some code. We also saw the if-else statement, which allows the program to execute another set of instructions when the condition is false. That is accomplished with an optional else clause. The condition itself, or the thing in parentheses, needs to be something that evaluates to a true or false, which can be a Boolean value, a Boolean variable, a comparison, or even a method call if that method returns a Boolean. We did an example of each of those in the previous lecture. Those examples only dealt with conditions having a single criteria, but a condition can also be a combination of any of those things, and that is a compound condition. The focus of today's lecture is understanding how to create compound conditions, where a condition is made up of multiple criteria. Making decisions involve all kinds of criteria. Never is it straightforward as a single criteria. As programmers, we need a way to express such situations where there is more than one criteria. Try not to get caught up in the semantics of criteria versus condition, because they are often used synonymously. If a condition contains only one criteria, then that criteria is the condition. If a condition is a compound condition, then each individual criteria make up the condition. Let's do a compound condition example. Let's revisit the umbrella example from the previous lecture. Originally, the situation was that it was raining, so we'll take an umbrella. But now, it's not raining, but it looks like it may rain later. So you may think, it's not raining, but it looks like it might. I should take an umbrella. So there's actually two criteria when we would take an umbrella: when it is raining or when it looks like it might rain later. To formalize that situation, it may look like this. If it is raining or is cloudy, then take an umbrella. So notice the original if-then setup, but there's this word or. We have the compound condition made up of two criteria: is raining or is cloudy. And we have our what to do, which is take an umbrella. Let's break it down using the if-then premise. Recall that the if-then premise, if some condition is true, then do some action. So in this case, the condition is it raining or is it cloudy? If that is true, then take an umbrella. So we have the first criteria, which is it is raining, and we have the second criteria, it is cloudy. The criteria are combined using the or to create a compound condition. So that or is a special key word. It is one of three Boolean operators. The Boolean operators, also called logical operators, are and, or, and not. There's three of them. Just as we have arithmetic operators that allow us to perform an operation using numbers, we have Boolean operators that allow us to perform operations using Booleans. And just like when you perform arithmetic operations, the result is a number, the result of a Boolean operation is a Boolean. So the Boolean operators are and, or, and not. The and is symbolized with double ampersands. The or is symbolized with double pipes, and the not is an exclamation point. If you have not typed the ampersand before, then you should take a look at your keyboard. It is Shift and 7. And if you have not typed the pipe before, it is Shift and the backslash key. So that's the key right above the enter. The and or Boolean operators are binary operators. That means there should be something on the left and right side of the operator. Just like arithmetic operators, plus, minus, divide, those are also binary operators. You have something on the left and you have something on the right. The exclamation point, that's a unary operator. It only has one operand, and that operand goes on the right side of the exclamation point. When you perform a Boolean operation, and or not, the result is a Boolean. So how would you know if the result is a Boolean, true or false? If you're dealing with the and Boolean operator, both the left and right operands need to be true in order for the and operation to be true. If either the left or right operand are false, then the result of the and operation is false. For the or, either the left or right can be true in order for the or operation to result in a true. If both the left and right operands are false, then the result of an or is false. You can kind of see that the and or, they are opposites of each other. And the and or, they are used to combine criteria. But the not operator, it is a unary operator. It only takes one operand, something on the right. So the result of a not is true when the original operand is false. All the not does is just flip the Boolean value. If something is true, it becomes false. If something is false, it will become true. Because the not is a unary operator, it is not used to combine criteria because it only has one operand. But the and the or, those have two operands. It's a binary operator, so those are used to combine criteria. When talking about Boolean operators and or not, it is customary to show you a truth table. So the result of an and, the result of an or, and the result of a not, given all possible combinations of true and false. So here is a truth table for the Boolean or. Now we have these letters X and Y. Those are just placeholders for the actual criteria given a situation. So these letters X and Y, they can be a Boolean value, a Boolean variable, a comparison, or a method call. The result of those things is a Boolean. So these are all possible combinations given two operands. The result of an or is indicated in the last column, X or Y. The result of the or operation is a true when either the X is true, the Y is true, or both is true. The only way for an or to result in a false is if both operands are false. So if at least the left or right operand is true, then the result of an or is true. To put this into perspective, let's take our umbrella example. We have the compound condition, is it raining or is it cloudy? The first criteria was, is it raining? And the second criteria, is it cloudy? So those would be our X and Y. The result would be whether or not we take an umbrella. So you can see that when we would take an umbrella, either it's raining, it's cloudy, or both is happening. The only reason why we would not take an umbrella is if it's not raining and it's not cloudy. Let's do another scenario. Let's revisit the free shipping scenario from the previous lecture. Here we have our assumptions. The shipping cost was $10, and you would get free shipping if the order amount was at least $25. Now let's expand that scenario to include a compound condition. So let's say that not only if the order is at least 25, you get free shipping, but also if you are a member, then you get free shipping, regardless of the order amount. Shipping is free for all premium members. So we have two criteria here to qualify for free shipping. either the order is at least $25 or you are a member and shipping is always free. So how would we express that using an if statement? Take a few seconds, pause the video. How would you say it in plain English using an if-then premise? Here's what I came up with. If order amount is greater than or equal to 25, or you are a member, then shipping is free. Okay, that's good. And what if shipping is not free? Then we'll add on the else. The else meaning the shipping is the flat rate $10. So the complete if statement in plain English would be if order amount is greater than or equal to 25, or you are a member, then shipping is free. Else, shipping costs $10. So if we break it down, we have our compound condition, order amount greater than or equal to 25, or you are a member. If that compound condition is true, shipping cost is 0. If that compound condition is false, then the shipping costs $10. If we were to take this situation and represent it in a truth table, it would look like this. The first criteria, X, that would be the order amount greater than or equal to 25. The second criteria, that would be Y, represents if the user is a member, and the result of the OR will determine the shipping cost. So you can see that the only way that the user actually pays for shipping is if the order amount is not greater than or equal to 25 and the user is not a member. In all other situations, the shipping is free. So either one of those criteria can be true in order for the user to get free shipping. All right, so that is us trying to logically think it through. We have not started to implement in code yet because if you do not understand the mechanics, when you start to implement it in code, then it's not going to make sense in there either. So first, you want to make sure that you understand the mechanics of the situation, and then you try to represent each part of this situation in Java, in computer code. So if we break it up and we start with the compound condition, order amount is greater than or equal to 25, or you are a member. So now we would need to express this in Java. How would we express this compound condition? So it is a compound condition with two criteria. So we would need to express the first criteria and we would need to express the second criteria. The first criteria is pretty straightforward. We've seen that from the previous lecture. If you recall, we have the input order amount variable. We can easily make a comparison, input order amount greater than or equal to 25. Now, in the previous lecture, we had the free shipping threshold variable, but for transparency, I'll just put a 25 here. But if I were to implement it in Java, I would replace the 25 with the free shipping threshold. But for this first criteria, we can easily represent it, input order amount greater than or equal to 25. Now for the second criteria, you are a member, how would we express that in Java? In this situation, either the user is a member or is not a member. It's one of those two things. What kind of variable do you think we can use to represent the state of the user being a member or not? Take a few seconds and pause the video. We could use a Boolean variable to represent if the user is a member because, again, either the user is or is not, and that's perfect for a Boolean variable. We can create a Boolean variable called isMember, and the value of that isMember variable would represent whether or not the user is or is not a member. So if we create a Boolean variable isMember, in order to express this criteria, we can say isMember equal true. This also means that at some point, the program needs to ask the user if they are a member or not, get the response, and then translate it to either a true or false. But for now, we're just logically thinking this through. We have a compound condition made up of two criteria. We can express the first criteria, and we can express the second criteria. Now, to put them together, we are going to use that Boolean OR with the double pipes. So putting it together, it's going to look like this. This entire expression is the condition of our if statement. So we have input order amount greater than or equal to 25. That is the first criteria. Is member equal true? That is the second criteria. Now, in order to combine them, we use the or, and the or is represented by double pipes. Now, how do you know if you're going to be using the double pipes or the double ampersands? That is going to depend on the situation. Typically, situations do actually use the words and or. So if there is an and in the compound condition, it is a good signal that you are going to use the double ampersands. If there is an or used in the compound condition, then that is a good signal that you will use the double pipes. So this entire thing is what would be in the condition of the if statement. However, we can simplify this a little bit because that variable is member. That is a Boolean itself. The equal comparison is not actually needed, and it's kind of a waste here. So because the is member variable is a Boolean itself, you do not need to compare it to see if it actually is true. You can just reference the variable itself because the variable represents a Boolean. So it can be simplified to just look like this. Input order amount greater than or equal to 25, and that comparison is grouped. You should always group your comparisons for readability. So that comparison is grouped, and then you have the or, and then just the variable name is member. Just like I showed you in the previous lecture with the is lecturing variable, we just stuck that variable name in the condition of the if. That is the same idea that's happening here. Because that variable is a Boolean itself, we can just reference the variable name. Now, if we were to take this condition and implement it in an if statement, then it would look like this. It would basically look like the example from the previous lecture, except now we have that add-on, or is member. And that's basically what a compound condition is. It's just a condition made up of multiple criteria, and they are combined using the Boolean operators. Now for this or, either one of the conditions can be true for the user to get free shipping. If they are a member, it doesn't matter how much they spent. And if they spent 25 or more, it doesn't matter if they are a member or not. For an or operation, either the left or the right operand can be true. The result of the or will be true. The only way for the result of an or to be false is if both operands are false. All right, so that is the Boolean or. How about the Boolean and? So the Boolean and, here's the truth table for that. We have the same x and y because the and is also a binary operator. We have all possible combinations of x and y, but notice that the only way for an and operation to be true is if both the left and right side are true. All other situations, the result of an and is false. So both operands need to be true in order for an and to be true. If we take a look at the same situation, but from a different angle meaning in the negative, so we'll be a little pessimistic here. If order amount is less than 25 and you are not a member, then shipping costs $10. Else, shipping is free. Now this is the same situation, just the glass is half empty point of view. We have the compound condition, order amount is less than 25, and you are not a member. We would need to express each of those criteria in Java, and this is how we would do it. Input order amount strictly less than 25, and to express not a member, we have is member equal false. If we represent the situation in a truth table, it would look like this. So the first criteria would be order amount strictly less than 25, and the second criteria is not a member. So in this case, the only way for the user to actually pay shipping is if the order is less than 25 and they are not a member. In all other cases, shipping would be free. And yes, like I mentioned, the and the or are opposites of each other. And if we were to implement this compound condition in an if statement, then it would look like this. Basically, the body of the if and the body of the else, they are switched from the previous example with the or. But if we use an and to represent the same situation, then the body of the if represents the user paying for shipping, and the body of the else represents the user getting free shipping. And just as we simplified the is member comparison, because the is member is a Boolean itself, we do not actually need a comparison. We can just use the exclamation point. So the exclamation point is the Boolean not. It will just flip the Boolean value. True becomes false and false becomes true. So for an and, both operands need to be true in order for the result of an and to be true. If either operand or both operands are false, then the entire condition is false. So let's take a look at this example, which I call English is hard. If you have taken the database class with me, then this may look familiar. So here's a fairly simple question. How many brown and black cats do you see? Take a few seconds, pause the video. How many brown and black cats do you see on the slide? In normal day-to-day language, you would say 5 because there are 3 brown cats and 2 black cats. However, this is logically wrong. The actual answer is that there is 0. There are 0 cats that are brown and black. You only see solid color cats on this slide. Solid brown, solid black, and solid green. But the question is, how many brown and black cats do you see? So when you are looking at each cat, it has to satisfy both criteria. The criteria of being brown and the criteria of being black. Maybe if there was a brown cat with black stripes or a black cat with brown stripes, then it would satisfy the criteria, brown and black. But given the cats shown on the slide, there is no one cat that satisfies both criteria. So actually, the question would be, how many brown or black cats do you see? So when you have an or, either the left or right operand can be true, and there we get the answer 5. So for the and Boolean operator, both operands, left and right, need to be true in order for the result of the and to be true. For an or, either the left or the right, or even both operands can be true for the result of an or to be true. All right, so let's continue on and let's look at the third Boolean operator, not. The not operator is a unary operator, means that it only takes one operand. So the truth table for not is fairly straightforward. The only way for the not can result in a true is if the original criteria was false. But just think of the not as flipping the Boolean value. If something is false, it becomes true, and if something is true, it becomes false. Now, why would you want to use the not operator to just flip something? Well, it turns out that some criteria is easier expressed in the positive and then just use the not to flip it. So for example, if I have this situation, I have a Boolean variable, hungry equals true. So we can assume that if the value is true, that means you're hungry, and if the value is false, that means you're not hungry. But if you were to use that in an if statement that looks like this, if exclamation point hungry, if that condition is true, we output the message keep working, else we output the message let's eat. So this if statement, the plain English is if I am not hungry, then keep working, else get something to eat. How about we do an example? So here's an if-else statement. What will print, true or false? You have a 50-50 chance here. What will print is false. Even though we have the Boolean value true in there, the exclamation point will flip the true to become a false, so the condition of the if becomes a false. And when the condition is false, that's when the else clause executes. So the message false gets printed out. How about this one? What will print? Same deal as the previous example, but instead of true, it's false now. So not false is true, and not true is false. How about this one? This should look familiar. What we'll print is true because 5 is strictly greater than 2. How about this? Not 5 strictly greater than 2. Actually, this one is a trick question. This is actually a syntax error. Now, you may have thought false because 5 strictly greater than 2 is true, and then the exclamation point will flip it to a false, and then false will print. But the exclamation point only applies to a Boolean, the thing immediately to the right of it. But the thing is, the 5 is the thing immediately to the right of the exclamation point, and 5 is not a Boolean. So this is a syntax error. If you wanted to apply the not to a comparison, then you need to group the comparison so that it evaluates first, because you can only flip a Boolean value. You cannot flip a comparison itself, but you can flip the result of the comparison. So you need to parenthesize the comparison so that it evaluates to a Boolean, then the exclamation point can flip it. So what will output is false. Now that we have taken a look at a handful of new operators, let's take a look at the operator precedence for them. As expected of unary operators, they are typically at the top. So you see the Boolean not along with the unary plus and unary minus. The arithmetic operators, turns out those have a higher precedence than the comparison operators. So any arithmetic gets evaluated first, then any comparisons. Then finally, you have the and or logical operators. Notice that the and has a higher priority than the or, and keep that in mind. So let's do some practice evaluating some compound conditions. I'll present you with a Boolean condition that is made up of true and false with logical ands and ors. What you're going to do is determine if the evaluation of that is true or false. So you have a 50-50 chance if you just straight out guess. And also keep this in mind, just like when you perform arithmetic operations, the result is a number. The result of a Boolean operation is a Boolean. So let's do our first example. Here I have a compound condition made up of trues and falses. What is the result of this condition? The result is false, and let's go through it. To break down this condition, there's the normal way of evaluating, and there's a shortcut. I'll show you both ways because the shortcut doesn't always apply. But going through each Boolean operator is the normal way, and it will always work. So when you look at this condition, the first thing you ask yourself is, where do you start? Just like in regular arithmetic, you always go through the innermost parentheses first. So we'll start with this, false and true. So what is the result of false and true? The result is false. Because we have an and operation, the only way the and can result in a true is if both the left and right operands are true. But since the left operand is false, the evaluation of this and is false. Okay, so we take this false and then we work our way out of the parentheses, and now we have false or true. What is the result of false or true? That is true. When you're dealing with the or, if either the left or right side is true, then the or will evaluate to a true. So since the right operand is true, the result is a true. So that will complete this parenthesized condition. That results in a true. And then you apply the last part, which is and false. Now we take the true and it with the false, and the result is false. Therefore, the entire condition will evaluate to a false. So you go through each Boolean operator and you evaluate it. When you're dealing with ands, both need to be true. When you're dealing with an or, at least one of them needs to be true. So that was the normal way of going through each Boolean operator. Here's the shortcut. We can see that this first part of the condition is parenthesized. It's grouped. We know that it will evaluate to something. either a true or false. But whatever that something is, it will get ANDed with the false. But it doesn't matter at that point what that something is, because the right side of the AND will be a false, and it will evaluate to false anyway. We as humans can make this determination using the shortcut because of our eyeballs, but parenthesized expressions have priority, so Java must evaluate this stuff in parentheses. Alright, so let's do another one. True or false and false. What is the result? The result is true. We can also apply the shortcut here because we have a parenthesized group which will evaluate to something, but it doesn't matter what that something is because it will be ORed with a true. And when you're dealing with an OR, as long as one of the sides is true, the result will be a true. How about this one? False or true and false or false. What is the result? The result is false. Now for this one, there is no parenthesized groups. So let's break it down, because even if you got the correct answer false, you may have gotten it for the wrong reason. So when you're looking at this expression, you'll need to ask yourself where to begin. Which one of these operators gets evaluated first? So you have an OR, an AND, and an OR. The AND will get evaluated first because it has a higher priority than the OR. Recall that table of operator precedence. The AND has a higher priority than the OR. So what is the evaluation of true and false? It is false. Now, we can already see that after this evaluation, it's going to be false or false or false. But for the sake of the breakdown and to be thorough, let's go through it. So after the AND evaluates, the first OR will evaluate with the result. So that will be false or false, which will result in a false, and that false will be ORed with the last false, and the result will be a false. So the overall evaluation of this condition is a false. Let's do another one. True or true and false. What is the result? The result is true. True and false is false, but you have true or false, and therefore the result is true. How about this one? True or true and false. The result is false. So with that grouping, it changed the result entirely from that previous one. But also we can expect it to be false because it shares the same setup as the first example, something and false. How about this one? False or true and false and false. The answer is false. And if we break it down, we have two inner parentheses. And just as in any other situation, you would start with the leftmost parentheses and work your way to the right. So the leftmost inner parentheses is false or true, and that evaluates to a true. The second inner parentheses is false and false, and that evaluates to a false. So the result of each inner parenthesis is ANDed together, true and false, and so the result is a false. How about this one? False or true or false and true. The answer is true. False and true is false. True or false is true. False or true is true. How about this last one? True and false or true. The result is true. The group false or true, that results in a true, and then true and true results in a true. Alright, so that should get you a handle for how the Boolean operators work. When you're dealing with an AND, both operands need to be true. If you're dealing with an OR, either one of the operands needs to be true. Now these Boolean operators and an OR, they're what's called short-circuited. That means the evaluation stops when the condition is guaranteed. Now what does that mean? So let's say you're dealing with the Boolean AND, criteria 1 and criteria 2 and criteria 3. So you have a bunch of criteria all ANDed together. If criteria 1 is false, then why bother evaluating the rest of the expression? If criteria 1 is true, but criteria 2 is false, why bother evaluating the rest of the expression? Once the condition is guaranteed, the rest of the condition is ignored. So let's say I take the situation from that previous slide and I replace it with some Boolean values. So for the first one, let's say I have false and true and true and true. At that first and, you have a false. So this stuff actually doesn't get evaluated. Once the first and is evaluated, it is guaranteed that this entire condition is false. It doesn't matter if there are 50 trues afterwards, because that very first one is a false, and that will just false everything else. And if we were to do that second example, true and false, and true and true and true, it doesn't matter if it's and true the rest of the way, because you have that false there. At that point in the evaluation, it will not make a difference. So the rest of the expression does not get evaluated because the condition is guaranteed to be false. Now for the or, either the left or right side can be true. So let's say if you have criteria 1 or criteria 2 or criteria 3, etc., you have a bunch of criteria that is or together. If the first criteria is true, then why bother evaluating the rest? So for example, if you have true or false or false or false, it doesn't matter because that very first or will evaluate to a true. So these will not get evaluated because the condition is guaranteed to be true. And that is short circuit evaluation. Once the condition is guaranteed, then the evaluation stops. But keep in mind the parentheses. If something is parenthesized, Java must look at it. So the first example, true or false, that is short-circuited. But the second example, because there is a parentheses there, Java must evaluate that false or false. Alright, so let's switch gears a little and see another application of compound conditions. Another application of a compound condition is when you are comparing numbers. Now, if you are comparing exact numbers, then you will use the equal comparison operator. But what about for ranges? Consider if a number is between some range. You will use a combination of comparisons and Boolean operators. So what do I mean by consider if a number is between some range? So testing if a number is in a range, that is what's called bounds checking, where you have a lower bound, which is the lowest a number can go, and an upper bound, which is the highest a number can go. Now, if you're going to be checking if a number is between some range, then you will have a lower and upper bound. So for example, if you want to check if a number is between 1 and 5 inclusive, and inclusive meaning that the lower and upper bound numbers are included in the range. So the number can be a 1 and the number can be a 5. Usually when you just say if a number is between 1 and 5, that is usually an inclusive range. It is implied that the 1 and 5 is included in the range. But there's actually two types of ranges. There's inclusive ranges and exclusive ranges. So I try to be as specific as possible. So when I express a range, I will either say inclusive or exclusive. The only difference is whether or not those end numbers are included in the range. Inclusive, they are. Exclusive, they are not. So if we wanted to check if a number is between 1 and 5, recall that in math class, you would express a range that looks something like this. 1 less than or equal to x less than or equal to 5. And x is the number that you're checking. If you try to do a direct translation using Java syntax, it actually doesn't work. That is actually invalid Java syntax, and you should not even try it because your program will not even compile. So what you have to do is express the lower bound, express the upper bound, and combine those two things. Because the lower bound is a criteria and the upper bound is another criteria. Computers execute instructions sequentially. So when you have to do some number comparisons, you should think of it as one comparison at a time. So we must specify the lower bound, then we must specify the upper bound. And because we just went through compound conditions, we need some way to combine those two things. So to express the lower bound, it can be like this: x greater than or equal to 1, or it can be expressed as 1 less than or equal to x. Both of those things mean the same thing. To express the upper bound, you could do x less than or equal to 5, or 5 greater than or equal to x. So we have a way to express the lower bound, and we have a way to express the upper bound. And then what we will do is use the AND to combine the bounds. We need to use the AND because both criteria need to be satisfied. In order for a number to be between 1 and 5, it must satisfy the lower bound and it must satisfy the upper bound. So here on this slide, I kind of illustrate that. The blue is the number line that represents all numbers greater than or equal to 1. The purple represents all numbers less than or equal to 5. So where those two overlap, that is the range of numbers that will satisfy the condition. So x greater than or equal to 1 and x less than or equal to 5. That will be the compound condition to express a number between 1 and 5 inclusive. How about an exclusive range? So an exclusive range is when the end numbers are not included in the range. So those would be a strictly greater than and a strictly less than. So on the number line you see, it is bubbled out to indicate that those numbers, the 1 and the 5, are not included in the range. Now, when you're starting to implement checking if a number is between a range, a common mistake is using the wrong Boolean operator. So what would happen if the Boolean AND was changed to a Boolean OR instead? So you have x greater than or equal to 1 or x less than or equal to 5. What kind of numbers would satisfy this compound condition? And here you'll see why this is no good. If you change the AND to an OR, then this represents any number. Because the OR, either the left or the right side need to be true in order for the compound condition to be true, this would actually accept any number because any number is greater than or equal to 1 or is less than or equal to 5. So for example, if x was 100, 100 is greater than or equal to 1, although it is not less than or equal to 5, it doesn't matter because you're dealing with an OR. Just the left or right side need to be true. And if the number was a negative 100, although it is not greater than or equal to 1, it is less than or equal to 5. So if you're trying to create a program that only accepts numbers between 1 and 5, well, actually, if you use this compound condition, the program would accept any number, and that's not what you want. How about this? This is another common mistake. What kind of numbers would represent this range? X less than 1 and x greater than 5. And the answer is no number because you're dealing with the AND, which would be the correct Boolean operator for a range, but the comparisons are not correct. Because you're using an AND, both the left and right side need to be true, but no number can satisfy being less than 1 and greater than 5 at the same time. So if the number is 0, yes, 0 satisfies less than 1, but it doesn't satisfy greater than 5. So no number would be accepted by this condition. How about this one? If I replace the AND with the OR, what kind of range would this be? The numbers would look like this, and this is kind of an awkward range, but it is valid and there would be numbers accepted by this condition. It is any number less than 1, any number greater than 5. So that orange that you see, those would be the numbers that satisfy that compound condition. And this would actually be the complete opposite of what the program should be accepting. It should only be accepting numbers between 1 and 5, but now it accepts any number that is not between 1 and 5. All right, so the takeaway is if you're going to be expressing a range, then you need to specify the lower bound, you need to specify the upper bound, and then you AND those two bounds together to create a compound condition. So with that, let's go into JGrasp and do an example of bounds checking. What we'll do is create a program that asks the user to enter an integer between 1 and 10 inclusive, and the program will output a message, the integer is within that range. This program is going to be called between 1 and 10. So let's go ahead and set up the program skeleton for a program called between 1 and 10. Public class between 1 and 10. Get our curly brackets, create the main method, public static void main string array args. And then let's go ahead and save. File save, click save, and then compile. Compile's okay. Now, since we're going to be asking the user to provide the integer, we will be using the scanner. So let's come to the top of the program and let's do some imports. Import java.util.scanner. And you may want to compile after importing the scanner to make sure it's correct. Okay, that looks good. And since we're asking the user for some numerical input, I know that the program may crash if the user enters something other than a number. So let's also use a try catch to compensate for that. Let's go ahead and import that exception. And that is java.util input mismatch exception. After importing this exception, we should also compile to make sure that the import is good. And I don't get any error message, so that went well. All right, so let's come to the main method, give ourselves some working space, and let's indent the code. Let's output a message to the user saying what this program does. So I'll do a println, and I'll call this bounds checker. And then let's do another line. And we'll say enter an integer between 1 and 10 inclusive. Okay, that looks good. Let's create our scanner to get input from the keyboard. So scanner reader equals new scanner system.in. And we'll also need a variable that stores the user input. So I'll call this int input int, and I'll initialize it to 0. So this variable will be used to receive the integer that the user entered. All right, what do I want to do now? Okay, so I have a message telling the user what this program does. I create a scanner to get input from the keyboard, and I create an integer variable to receive what the user entered. Now I want to use some kind of prompt, a prompt that will indicate to the user to enter in something. Now the prompt that I'm going to use is a little funky because this is the first time I'm going to use it. I'll print out a single angle bracket as the prompt symbol. You can have your prompt as this message here, enter an integer between 1 and 10 inclusive, and then use a colon and use that as your prompt to the user. But I'm going to use this angle bracket for this lecture and also for subsequent lectures. So the prompt is just to indicate that the user is supposed to be typing something. So when the program outputs the two messages up here, bounds checker and enter an integer, then they'll be presented with the angle bracket as a prompt, indicating that the program is waiting for something. So just to show you what I mean, let's compile and then run. So I want the user to enter their number here. So they'll see the message of what to do, and then the program will wait for the user to enter something here at the angle bracket. So I'm just using this angle bracket as my prompt for this example. So once I have the prompt, I want to get the input from the user. So I'll take my input int variable, and I'll also use my reader and say go get input as an integer. So input int equals reader.nextInt. That will retrieve input from the keyboard as an integer and then store it in my variable input int. Okay, so now that I have the number that the user entered, now I want to check it. I want to check if that number is between 1 and 10 inclusive. And inclusive meaning that the 1 and the 10 are valid numbers in the range. So here, I'll start an if statement. I'll say if and then I'll have my condition. Now, if you are checking for a number between a range where you have a lower bound and an upper bound, you'll need to express the lower bound, express the upper bound, and then AND those two criteria together. So here's what I'm going to do. I'll first express the lower bound, which is input int greater than or equal to 1. Okay, that is my lower bound. So the lowest number this program will accept is 1. And then I'll have my AND, the AND Boolean operator. Because if you're checking for a number within a range, the number has to satisfy the lower bound and the upper bound. Then I'll make my criteria or my comparison expressing the upper bound, and that would be input int less than or equal to 10. So input int greater than or equal to 1, that's my lower bound, and input int less than or equal to 10, that's my upper bound. Now, when you have your comparisons, you should parenthesize them for readability. So I'll parenthesize these two comparisons. So if a number is between 1 and 10 inclusive, it needs to satisfy both of these criteria. It needs to be greater than or equal to 1, and it needs to be less than or equal to 10. Okay, so if that is true, then I want to output some message. So let's use a printf for that. So system out printf, and we'll say, yes, that integer is between 1 and 10 inclusive. We'll end the format string, and then we'll list the variable to format as the input int. So if the integer that the user entered does satisfy the condition, it means that it is between 1 and 10. So the body of the if will execute, and it will output, yes, that number that the user entered is between 1 and 10 inclusive. Okay, so at this point, you may want to check if the program is working correctly. So let's recompile and let's run. So here I have my messages to the user, what the program does, and here the program is waiting for the user to enter something at that angle bracket. So enter an integer between 1 and 10. Let's do a valid case. I'll hit 5 and then enter, and then I get the message, yes, 5 is between 1 and 10 inclusive. Okay, so that looks good. Let's check the edge cases. So the edge cases are the 1 and the 10. So if I do 1, it should be accepted by the program. Hit enter, and okay, it's verified. Yes, 1 is between 1 and 10. And let's do the other number, 10, because 10 is the highest that this program would accept. I'll hit enter, and yes, I get a confirmation saying that it is between 1 and 10. Now, this only works for integers, so let's do a very high integer. So let's do 100. I'll hit enter, and I get nothing. So the fact that I get nothing at this point means that the condition was false and the body of the if did not execute. So now I want to compensate. What if they did not enter a number between 1 and 10? Then I'll use the else clause, which will represent some number outside of that range. And I'll say system out printf, pretty much the same message, but we'll say no. That integer is not between 1 and 10 inclusive. And we'll list the variable there. So if it is between 1 and 10, we say yes. If it is not, then we'll say no. So let's recompile and then run. Enter an integer. Okay, let's do 100 this time. No, 100 is not between 1 and 10. Okay, that looks good. And if I do negative 100, hit enter, and I still get the no. Negative 100 is not between 1 and 10 inclusive. All right, so this looks good. We compensate for all possible values of integers. We tested some very high integers, some very low integers, and we tested some integers that are actually in the range. So if I run the program again, and if I do 7, hit enter, then yes, 7 is between 1 and 10 inclusive. All right, so now the program works if the user follows directions, meaning they enter an integer. So now comes the time to crash the program and see what kind of exceptions come up. So if I run the program again, and now I'll enter something not a number. So if I say no, and then hit enter, then, oh, okay, so my program crashed. It crashed on line 16, which is kind of expected because that's the next int method. And here I have the exception input mismatch exception. Okay, so if the user types in a word, I get the input mismatch exception. What if they type in a non-integer? So what if they type in a number, but it's not an integer? So for example, 10.0. 10.0 is a number, but it is not an integer. So if I try it and hit enter, then it looks like I get the same exception. Okay, so input mismatch exception, and it's being thrown on the same line, line 16. All right, so I know where the program crashes, here, and I know the exception that is thrown, input mismatch exception. But I kind of already knew that because I've imported the input mismatch exception at the top. I'm just confirming that exception is thrown. All right, so I have where the exception is being thrown. So now I need to set up my try catch. So I need to identify all the things that I want to put in the try and what I want to do if the exception is thrown. So I usually have the prompt included with the risky line. So I know for sure I'll be adding these two lines in the try. But what you also add in the try is code that is dependent on that risky code. So the risky code is getting the integer from the user. If there is something wrong with getting the integer from the user, there is no reason to test if that integer is between 1 and 10. So I will also include this if else in the try block. So if the exception is thrown on this line, this if statement will be skipped and it will go down to the catch block. All right, so let's go ahead and set up the try catch. I will also label my closing curly brackets here. So this one closes the main, and this last one closes the class. So I know not to mess with these two closing curly brackets. So actually what I want to do is put these things, this entire thing, I want to wrap it in a try block. So here's how I'm going to do that. Above the print instruction here, I'll place my cursor on this line. I'll hit enter, and then I'll start the try block. And where I want the try block to end is here, after the if statement. Okay, so this whole thing now is in the try block. And to further signify that, I will use the CSD button to indent the code and then turn off the CSD button. And then I can see that everything was successfully wrapped in the try and everything is indented. Okay. If I try to compile at this point, then I'll get an error. It says try without catch. So immediately after a try, there needs to be a catch block. So after the try, I'll do catch. And the exception we're catching is input mismatch exception. And I'll name this exception variable IE, closing parentheses, and I'll have my curly brackets here. So what do I want to do if the exception is thrown? I'll just output a simple error message. I'll say error. Please enter an integer between 1 and 10 inclusive. So I'll just repeat the message back to the user, just like that. Let's recompile. Recompile's okay, and now let's run. So enter an integer. If I say no and then hit enter, then I get the error message. Please enter an integer between 1 and 10 inclusive. If I run again, and if I do decimal 10, so 10.0, hit enter, then I get the error message. If I run the program again, and let's do some actual integers. So if I do 100, hit enter, then I get the no. 100 is not between 1 and 10 inclusive. So I get this message instead that happened in the else clause. And I get no other message in the output, which means the program just ended on its own. If I run the program again, and if I do 3, hit enter, and then I get the message, yes, 3 is between 1 and 10 inclusive. So this program looks like it is running as intended. We compensate for all valid and invalid integers. If the user did not enter an integer, so they enter a decimal number or they enter a word, that will be caught in the input mismatch exception. So that will complete the program It asks the user to enter an integer, uses an if statement to check that integer, but the try catch is there to compensate for any non-integer input. Also note that we are starting to nest things inside of other things. So we have a try, and inside the try, we have an if. Try catch is a nested structure. If else is also a nested structure, which means that you can also have another if statement inside the body of the if. You can have another if statement inside the body of the else. You can have an if inside an if, inside another if. You can have an if inside an else. You can have a try catch inside an if that makes sense. But note that we are starting to nest these things inside our program. So it's important to have good indentation. Use the CSD button to get that indentation, compile, and try to run your program every step of the way so that you create your program in pieces. That's going to be it for this lecture. If you have any questions, please let me know.